No.
Okay, I'm starting, right? Okay. Hello, everyone. Today we are going to present a paper published in 2024 by Vong et al., Ground Language Acquisition Through the Eyes and Ears of a Single Child. I'm Lipeng, in Monash University, working in Tsuchiya lab, now presenting as a research assistant. Mike?
I'm Mike. I am a first year PhD student in the same lab. I'm Vishaal.
Yeah, I'm Vishaal. I'm also a master's student at the same lab. Yeah.
Yeah, my name is Chuyin, and I'm a PhD student in the same lab with them.
I'm Kyoko, a candidate student of the same lab.
I'm Ryuto from Yamada Laboratory. She is a collaborator with Jiao's labo and master's student.
All right. So before starting, we need to first clarify what is grounded language. So language is grounded in experience. It is not just an abstract or symbolic. They are grounded in our real life experience, real life context, and our interaction to our environment. Right? So people need to interact physically with their word to grasp the essence of the word, like the red, the heavy, and then above this kind of word. So in this paper, essentially discussion two modality, visual and auditory, that help children or infant to grasp the meaning of the word. All right. So for this paper, grounded language acquisition through the eyes and the ears of a single children, what is the major research question? So children learn words from around 6 to 9 months old. So here, the learning means that they connect the spoken words to their visual counterpart. All right. So Vong et al. Ask, how do children get started on word learning? The learning is right, connect the visual counterpart with the spoken word, and what kind of learning mechanism and the representational commitment are needed for this word learning. And previous studies say that there was 3 accounts answering this kind of question. So first account, word learning is driven by a simple and a domain general and associative learning mechanism. Second, word learning was constrained on the innate knowledge or domain-specific inductive bias. And third one, the word learning needs to be supported by cognitive ability. All right, so these 3 accounts are supported by lots of evidence in lab setting, But there are several questions that previous research on this lab setting research cannot answer. The first one is because they measure this learning mechanism in different time point of development. It is hard to infer the relative importance of this factor, of this mechanism. And it also provides insufficient guidance for building a computational model that can be generalized outside the lab setting. Remember, we made model and predict future. So the goal is to have a computational model that can be generalized outside the lab setting. So previous research didn't met this goal. It is also unclear that associated learning in conjunction or along with the feature-based representation, is that enough sufficient for word learning? It is still unclear. So the present study by Vong et al. Target the first account, associative learning account, to investigate what degree infant can learn from visual language association, that is the learnability of word reference mapping. Okay, so to instantiate the associated learning, they introduce contrastive learning model. We say CVCL at this moment. CVCL is a type of machine learning model in an unsupervised manner. They associate the associative learning input will be the longitudinal head-mounted video recording around 61 hour. Okay, let me share my screen. Let's get a intuitive understanding of this. Okay, so this is baby and this head-mounted camera. All right. The machine learning model CVCL then will learn by temporal co-occurrence between visual stimuli and auditory stimuli in an unsupervised manner, unsupervised way, just like what babies do. For example, see figure 1b. For example, if there is a butterfly in visual field, well, the model also hear that a butterfly at the meantime, so they will learn this. They will learn this association. Right. So let's go to the result section. After the model training, trained by this 61-hour video material, they got 3 findings from the trained model. So first, they found that the model can occurred word reference mapping from 10 to hundreds of example. The classification accuracy of the CVCL. Here, the CVCL is the model trained by their data. Okay, I will not specifically say that model. I would just say CVCL. Okay, the classification accuracy of the CVCL trained by their data was 61.6%. And compared to CLIP, it just dropped down 5.1% of accuracy. So to know that, what is CLIP? The CLIP was trained by over 400 million image text pair on the internet. So CLIP is a more powerful model. So we can see that a CVCL performance is comparable to this such kind of strong web scale very strong CVCL model, which is a CLIP. And generalized, the second finding is that they found that this model have a generalized zero shot to new visual data set. That means that this kind of model is able to recognize and classify objects that it have never seen before, never seen during the training. They tested by evaluating the CVCL performance on the Conco objects evaluation dataset. Okay, so results show that the CVCL multimodal representation can permit so-called out-of-distribute generalization. Although, out-of-distribution generalization refer to a model's ability to generalize data or situations that are significantly different from the data it was trained on. So remember, the data they train is using a real-world video recording, and then the data they test is a white background objects. Is called Conco object evaluation test. So although the overall accuracy was only 34.7%, but they also higher than the chance it's 25%. Okay. The third finding is that the model achieved cross-modal alignment. So that is the visual and the language modality, this cross-modal alignment. So in this part, what I want to highlight is the figure 5. In the figure 5, this looks very similar to humans' eye tracking heat map, but it actually is the attention map of CVCL model of Yes. This was conducted by a called great cam technique. So this techniques allow us to quantitatively interpret the black box of the convolutional neural network. Okay, I will again share my screen. Okay, GrandCam. It consists in finding out which part of the image has led the convolutional neural network to its final decision. So in this case, this model was trained by it is a network of dog and cat, and then you can see when you input cat, this one highlight the cat here. And then when the input is dog, it highlight the dog. So this allow us to quantitatively explain this kind of black box. Very amazing. Okay. Let's see. We can see that in the figure 5. Okay, let's go back to figure 5. We can see that in the figure 5, their multi-modality, this kind of multi-modality model, CVCL, can do cross-modal alignment that bring us back to our associated learning account, right? The temporal correspondence between visual and auditory stimuli of their training data set allow this machine learning model showed word referent mapping ability, especially in an unsupervised manner. Unsupervised manner means that we don't have label, external label. So to conclude that, the CVCL's focus on learnability with minimal ingredient shows how this kind of representation learning and associative cross-situational mechanism are sufficient to occur word reference mapping from one child's first-person experience. That means that again, it is an unsupervised model. It means that we don't need to any label any semantic information, just using this kind of video with the visual and auditory input, then the learning just spontaneously appear in this kind of machine learning model. So to me, this is very interesting study because visual experience and auditory experience, these two kinds of modality allow machine to have this kind of learning ability. So that's why I'm so interested in this paper. Okay, that's all of my summary. Do you have any question or?
I want to ask for a clarification.
Okay.
So on the first page, it says trained in a self-supervised manner. So so I wonder why you said unsupervised model, because I don't remember I see any unsupervision or relative terms in the paper.
Oh, okay. So that is maybe that's my interpretation because self-supervised it doesn't I mean unsupervised. The unsupervised I mean is that we don't need external label. For example, recruiting MTurk participant to label this image is dog and a cat. They just do it in their algorithm. I don't know whether my interpretation is correct, but that's what I mean by unsupervised. So maybe this confusing terminology.
Yeah, I mean, from a quick Google search, I mean, it shows that self-supervised learning is just a type of unsupervised learning, like a subset of unsupervised learning. So yeah.
Okay. Yeah,
Yep.
yeah.
I do actually have a question about the first result that they get.
Okay.
So it talks about around 60% accuracy, and later on it talks about when they're using very different kinds of stimuli, the model got around 30%, I think. So the stimuli they used for the 60% result one, was it supposed to be the footage they captured from the the camera that's strapped on the baby's head are those where these test footage originate from.
Sorry, where is 30%? Do you mean the
sorry.
figure 2?
Give me a sec.
Randomized features, that one, the orange one?
So when it talks about generalizing to novel visual exemplar, it mentioned, I can't remember. What's the average though? The overall accuracy was 34.7%.
Ah, that is the zero-shot classification, right?
When they are facing novel stimuli.
Yeah, okay.
But previously there was around 60% one, right? In the
Ah.
first result.
Mm.
What stimuli are they using exactly? Because based on what they have described, it seems to me that they are using stimuli that came from the footage they captured with the camera that's strapped on the baby's head.
My understanding is that the task is different. So for the 60% one, you can see in the figure 1 CD, the task is to, for example, asking which one is ball, and then the model will choose one of the 4 image, right? But for the 30% one, the task is a little bit different in figure 3B. Yeah, that's my interpretation.
I'll say for test example. Maybe I misunderstood it, but what task are they doing in the figure B exactly?
Figure B.
So the one figure 3B, sorry.
Figure 3B. Then I'm not 100% sure. I also have a little ambiguity in this part.
Yeah, because if you look at the first sentence of the generalizing to novel visual exemplar section, it specifically refers to figure 1B.
Figure 1D.
Yep. And figure 1D is the novel stimuli. So I was under the impression that figure 1D is the task they used.
Oh, I see. So the novel means that the background is white, mimic the laboratory setting. And then yeah, the C is I think it is retrieved from the training movie, I guess.
The training movie was essentially captured
The training
from the
yeah. Okay. Yeah. Okay. Yeah, that's a good question. I also have a same ambiguity relating to generalizing to novel visual exemplar section. Anyone has understand this?
Which aspect of it?
No, I mean your question. I'm asking, is there anyone can answer your question? Okay, just keep it.
All right. Okay, yeah. So essentially they tested using familiar stimuli, get 60%, around 60%. They tested using novel stimuli, got around 30%. That's essentially the takeaway.
Yeah. Yeah.
I would agree with the interpretation of the background thing, or it's like whether or not the object is in in a context that have been seen in the training, or it's just a single object. Like, yeah, I would agree with that interpretation.
Right. Are we moving to discussion session?
Yeah. Any questions, I suppose, from other folks?
So far, do you guys know what's this linear prop model?
Not 100% sure, but my impression is that this is a super powerful model that using external label, so the accuracy will be very good.
Yeah, but it looks like some, say, cracked answers, like it provides a ceiling for the performance.
Yeah.
That's why I'm asking where this is from. Yeah.
My understanding is this model is a linear fit with neural networks similar to CVCL with respect to vision and pre-labeled categories with respect to language. So it is more, accurate label is already given.
That's how did it work? How did it work? Linear fitted with what? Can you say again?
I'm not sure about what is the proof and
Linear fit, okay.
Linear fitted to visual, because I'm a complete novice to machine learning. So if you can introduce it more a bit,
I'm not perfectly sure, but I suppose
linear.
in CVCL there is two neural network models. So we have to it have to learn the category of the text, so language information, and also the vision, so from the video. But in this linear probe model, the language information is already given. So so this accuracy is 100%. So it wants to see about the accuracy about the contribution from the language simulation of natural model, STEM simulations. Can you understand what I'm trying to say?
It sounds like we have a pool of labels and a pool of stimuli, and we know there are potential one-on-one matches, and it just fitted with corresponding ones. So that's the reason for higher accuracy.
Yes, so the language recognition is all already learned from another data set, very large data set. So it's really accurate.
Right. So just to try to help me understand this, the labeling would look like if the baby have a picture of a duck in a pond, there will be a human look at the picture, they will write down duck in the pond, and the AI will use these data to essentially train its own train and generate result. Is that the idea?
Sorry, Mike, can you repeat that again? Can you repeat that again?
So essentially, you have a lot of data that's essentially artificially created, where you have these pictures and then there's a label that's manually written for this specific picture. And the AI use these combined data to train and generate predictions and so on and so forth. Is that the idea?
Maybe, I'm not sure.
Basically, I think that this linear prone model has very accurate about language. So it wants to see the contribution of natural language stimuli. So this understanding is enough, maybe, perhaps, I don't know.
Does anybody remember why they are using these linear probe?
Oh,
I think the linear probe is useful for the classification task. So using the CVCL's model, the some kind of feature. So I think it's enough for understanding the difference. So it can test the model whether the model have the significant characteristic some kind of object, the word or something. I think. How about Lipeng?
You ask why they use linear probe model? Yeah, I think in some machine learning paper, they are testing upper and lower limit of a model. So to my understanding, linear probe is some kind of upper limit ceiling. So they're used for comparison how CVCL performs in this certain kind of task. In figure 1, it is classification, as Ryuto said.
Right. So it is, the purpose is to, by using this supervised model and compare the unsupervised to the supervised, we get an idea about where the ceiling is and where the current model's performance is comparing to the ceiling. Is that the idea?
Yeah, I agree with you. I would
Okay.
say, yeah. All right. Further question?
Yeah, I'm familiar with language learning research and like language models and stuff like that. So I was just curious, is the classification accuracy for the word reference mappings, right? Is 61% like the average performance for current models, or is it considered high, low, average? I was just curious about that. I don't think they really mentioned it because I know it's 5% less um accurate than CLIP, right? CLIP had like 66% accuracy, and then CVCL has 61%. So I'm just trying to understand, is the purpose of this model is to have more promising accuracy, or is it simply like a way for us to learn how language is learned in children?
The purpose is to answer whether just visual and auditory stimuli paired together, this kind of stimuli is sufficient for
Right.
assessment learning. And the clip is some kind of more 400 million pairs of visual stimuli and the external label. So this is a super powerful model,
Yeah.
but the clip don't have auditory stimuli
Yeah.
input, right? This is not a cross-model model.
Yeah.
So only with our curtain CVCL cross-model model, just one child data, 61 hour, very limited data compared to clip, it is very comparable. The performance is very comparable to
Yeah.
that kind of powerful model. So
Yeah.
I think that's what the author want to convey in.
So the current 61% accuracy is essentially the standard, right? It's the so far current existing models, like around 60 to 70% is like the average performance. So
Yeah,
right? Okay, I was just curious about how it stacks up in like current
I want
literature.
to
Yeah.
add something like the stimuli in the CLIP model should be more controlled, but here the training material in this in the CVCL model and it's more naturalistic. So when the materials are from a natural setting, it's gonna be more noisy. So this accuracy, yeah, I will say it's quite good. Yeah.
One more thing to add, I suppose, is that an important aspect of the CVCR model is that they can have this temporal relationship between the visual and the language. and they are constructing their vector space essentially based on how closely aligned two things are in the temporal scale. So I think that's going to be a major difference as well.
Isn't that an assumption of this whole study, like temporal associations? Did they assume that what the child is seeing and what a person is saying are associated together? That's assumption, right? Important assumption, I think.
Associative learning.
Yeah.
If you look at the cosine similarity, well, in figure 1b, and the description related to it, it seems the cosine similarity is either entirely determined or partially determined by how close the two event occurs together.
Yeah.
And I assume clips, well, it doesn't have anything like that, and it's just a picture and a caption.
Okay, so it's like this clip considers one parameter fewer than this CVCL model. Yeah. Like you're using time difference or co-occurrence as a parameter in the model?
Looks like it.
Okay. Yeah, that's probably too technical. Yeah.
I then I have another question or something I want to discuss. Okay, can you see the screen? Oh,
Yeah. Not knob. Saw it. I saw it. Okay.
problem, right?
Boring, bland, distinguish.
Okay, so this problem, which screen you are looking at? What?
Oh, sorry. We are seeing the highlight.
Google Chrome. So this one.
Yes, we are looking at the page.
So it asks whether a man who has been born blind and who has learned to distinguish and name globe and cube by touch, only by touch, okay, can be able to distinguish and name this object simply by sight. It means that if a congenital blindness people learn object recognition only by touch, after regaining the sight, can they identify that object quickly by their mental representation learned by touch? So this question is a little bit hard to investigate in human participant, although there's a research investigating this on human participant. But I'm thinking whether we can do this similar in machine in model. So train by one modality and then test by the other modality. To investigate this philosophical question, I'm not sure whether.
I mean, to answer this, oh, sorry, Chuyin, go first.
Sorry, I feel a bit weird to consider semantic knowledge as a modality here. I don't know what you guys think.
I mean, I suppose it's a bit weird, but this what semantic represent is an abstract, some sort of representation of the object, right? So maybe that makes a little bit more sense.
Oh, okay.
But okay. But I
mean,
get what you mean. Okay, sorry, wait, go.
Yeah, no, sorry. No, just to answer this philosophical question very quickly, right? Like without thinking too much about it. Wouldn't the very quick answer be yes, they can after regaining their eyesight because of learning about concepts, right? If the people who are previously blind learn that a sphere, a globe, right, doesn't have any edges and it's just completely smooth and rounded, right? If they see for the first time, wouldn't they pair object and concepts together? I don't know.
Yes, they can, but the learning rate or the speed of learning is
Oh yes.
vary. There's
Yeah.
some research have do this, and then they can actually quickly learn within 2 or 3 days. But throughout the development period, for example, if a congenital blind after regaining their sight at the very young age, the neuroplasticity is different to the old people, right?
Yes, yes.
That's my question or some thinking during when I read this paper. But yes, I agree with you. The semantic knowledge is more abstract and symbolic kind of thing. That's a little bit weird.
I almost want to say we can't do it with AI, right? I feel like, well, because in this case, the AI is trained cross-modally in a sense, based on visual and language. But if you let's say if we show this model that we have trained a set of auditory data, or maybe even textile data, well, what's the model going to do? It's not going to do anything, right? It's going to make chance level responses, right? If you train a person or a model solely on auditory or in touch, and then you suddenly present it with videos, is it really going to do anything at all?
What do you think, Kyoto and Ryuto?
It's a difficult question, but in this morning I watched a video about some kind of robots. This robot doesn't have the camera, but it have the sensor of some kind of texture. And someone hit the robot, and it how to say it lowering and lowering, but it's after that it stand alone. So it means that this robot have the how to say the world model in that model how to say the robot can detect the robots how to say the place of the robot in this in that circumstances. So this means that the texture can make the word model. So it's like how to say a little bit meaning for this question by this case. So and if we are asked, but we depending on the how to say seeing. So it's difficult for to understand the circumstance by texture, but so for the development, early development stage, and develop on the primary develop the texture or something. So it will be, I think. Is that answer?
That's exciting. Sounds like very fun. Will you attend the Qualia structure meeting?
Later.
Maybe we can discuss afterward. Okay.
Okay, and I have another question. Is it okay? Yes. So what is the accuracy rate of the infants in this task, the clarification task? So is it enough the 61.6% to conclude it reflect our ability of the language? The 61.6% is enough for our ability. Do you make sense?
Wait, do the infants have enough semantic knowledge to do the task?
Yeah. At least at the 2 years old. Yeah. But yeah, I think I agree with you. Yeah, it's difficult for to do that.
25 months old, right?
It's enough,
Yeah,
right?
there's some kind of experiment design. So I think
It's enough to do the task, I feel like. They have learned some words and they would be able to identify. But it's difficult to say what exact percentage would it be. But I have to imagine it's very high, right?
more than that 60.
I see. So you want to compare the performance of infant and then this CVCL model. Yeah. I think that's feasible, but maybe we need to do some other paradigm, do this in other paradigms.
Or maybe use slightly an older children. At least I don't think 1 year old, the 1 year old can do it. Yeah.
And the one additional thing I want to mention is that the video recording, the language input this infant receive is actually infant orientated language. So it is not like our talking. It is like it's a baby. Wow, look at a baby. Now it's a big ball. This kind of language.
But the training example in figure 3, it's like it's a duck and a butterfly. You want to pour that in the bucket. I believe these languages are from an adult, right?
Yeah, from adult, but it is talk with a baby. You know, the mommy say something to baby. It is very I don't know how to express this kind of baby orientated language.
Okay, so it's like a baby style.
Yeah, baby style.
Yeah. Okay.
That means that this model is trained by baby style language and visual experience. That's how I want to highlight it. Okay.
Yeah.
I have a complaint. Not sure if this is a real discussion, but we will see. The paper claims that it is trying to make a point on the fact that associative learning alone is sufficient for perhaps the infant to develop this word reference map between their language and external. But if that's the sole purpose of the experiment, while it remains interesting, it feels somewhat less significant in terms of the result. Just because while it confirms that yes, it's sufficient, it doesn't really block out many of the other alternatives. They can coexist, right? Be it induction or other forms of higher cognitive functions.
Yes, of course.
Yes. But if you look at this paper from the perspective of training an AI model, how to effectively train an AI model using limited set of data, all of a sudden, this paper become very innovative and very significant. If you will just follow up from Ryuto's previous question on comparing child's performance to this AI, if this paper is genuinely only focusing on children's language learning, then that's something worth doing. But it's not doing it. It's comparing it to many other models to see how well it did, right?
Yeah.
So I feel like they are discussing their experiment from the less interesting angle, I suppose, was my complaint.
It's, well, I guess, no, they are, yeah, the authors Okay, the authors are from data science background, so okay.
It could be interesting to those data scientists or machine learning guy. Yeah, but I agree with you. If it compares children's performance and the AI model, that would be much more interesting.
I suppose just to further the discussion, one additional point was that uh, the associative learning, this temporal co-occurrence, is like the simplest form of all the conditioning that we found in humans and animal learnings. And so far, it's presenting exceptionally good results based on what we have seen, right? 60,000 video clips, and it's already generating good accuracies. So what if we apply more of the thing that we learned about conditioning to model design and model training, I suppose? Would that produce even more spectacular result? Like if we give the model some sort of extinction function, well, who knows what could happen, right?
Yeah, and also the CVCL don't have others modality, taste, touch, and smell. And then we know that infant learning is actively, the learning model is passively receive information, and then children learning actively interact with the environment, and also some embodied experience also appear in children's learning. Yeah, that's much limitation in this model. But
I
so
have
far,
another question. Oh, I'm sorry.
oh, no, please.
Okay, I have another question. So in this paper, the first question in introduction was there were two theories, and one was what learning is driven by simple domain general associative learning mechanism, and another was such there are another constraints in such as domain specific inductive biases. So according to this result, is it correct to this paper support the former hypothesis? I didn't understand which condition, which model was associated with the some constrained learning.
I feel that this research mainly focused on the associated learning, which is the first account, addressing the question is what ingredient do the children needs to learn the words. So the paper answered that, given their everyday experience, this kind of joined representation and associated learning is not we cannot say it is absolutely sufficient, but the performance is satisfiable to the author. I think that's they want to say. The key question is, what kind of ingredient do children need to learn the words?
So in the first, this paper's hypothesis is a former, just associative learning.
Or mainly focused on the associative learning? What do you think?
I suppose so, but I want to ask other people's opinions.
Do anyone have such?
I was under the impression that the hypothesis was that they are trying to find the minimum requirements for language learning to occur, which is why they chose the associative learning. And like all sort of organisms have associative learning without the need for higher level stuff like inductions, categorizations, so on and so forth. So that was my impression.
Thank you. Mhm.
All right. Do we have any other further comment? Okay. I think that's all for today. Wait.
Right.
Thank you.
Thank you.
Thank you.
Bye.
Well, all right, bye. Thank you for coming. Come back next time for more journal club. Yes, yes. All right, bye-bye.